Good morning, guys. So today I'm using another method of taking class. I will be using whiteboard, so that it will be very close to you guys how I am writing. Okay. So let's see if you are comfortable with it. Not, but I think you will be comfortable because we did the same during the live class, right? So as I speak, during the live class we completed the dimensions introduction part. So how to write the dimensions of a physical quantity. Then we also found one application of physical quantities, right? So during the live class, we finished these and all topics, that is dimension, right? Then the first application of dimension was what? To find the consistency, right? So find the, or to find whether a equation is consistent or not, checking the consistency. That is the first topic which we covered, right? Now today we'll be dealing with the second use of dimensional analysis, right? The first one we have completed. The second one is to know the relationship or to deduce the relationship between physical quantities, right? So what do you mean by that is you will be given parameters like say velocity. So what is and you will be told that there are two quantities on which the velocity depends on, but in which way, that is what is the power of that equation or how to derive that equation where velocity and time and distance is depending is used for this criteria. That is, by using dimensional analysis I am going to find the relationship. Let's take an example, guys, then you will understand what I am talking about. Because, and I think the dimension section entirely, if you have to understand, you have to take an example. Let's take an example of a mass m, and I want to move that mass through a distance L from one position to another position, right? So while I'm moving, in order to move this mass from this initial to this final position, I have to apply what? A force F. Right. So this force F depends upon these two or this mass. This not the two, only one mass is there. So I can say F, that is a force. Let's write it as capital letter as in the figure. F is actually function of, right? Depends on or can be written in mathematical form as function of what? Mass of this block M, let's say. Then what? Length through which it has to be moved, right? And time through which I am going to apply the force. Let's take it as t, right? So I can say force which I have to apply to move this block from one position to another position is a function of mass of the block, length of the distance which has to be traveled, and time for which I am going to apply the force. Now this function F can be written in another form, right, which you have learned earlier. That is, I can write it rather than equal to, let's make it as proportional. Okay, so F is proportional to what and all term? Mass, and I will take a exponential function A. I don't know its value, okay, some exponential function, and L raised to B and T raised to C, right? I don't know the values of or the exponential functions of m, l and t, that is a, b and c. That is my job here. I have to find a relationship between the physical quantity force, mass, length and time in this example, right? And that is, I have to find the values of a, b and c, but there is a proportional value here. So in place of proportion I'll write a constant, right? So that F is equal to k into m raised to a, l raised to b and t raised to c. This much is clear, I think. And what is our end result, or what is our new job? We have to find the values of a, b and c, right? So that I can write force in terms of mass, length and time in this example. Okay, in this example means I have to move a block mass from one position to another position of length L, right? So these A, B, C values I have to find. So how can I do it? So that is, all the questions are of the same format, guys. You just have to follow the same steps. Clear? So in the LHS part, what was written? Force, right? And I am writing the same equation, guys, right? It's because I wrapped it off. So m L raised to B, T raised to C. Okay, so in LHS part we are having force, that I can write it as what? ml T raised to minus 2. What should I write? K m raised to A Right, same. I will write it in the bracket form so that it's very easy to understand. Ma raised to b raised to t raised to c. Now, what should we do? We have to equate LHS parts m with the RHS m. Similarly, L and t. Okay. That means the m quantity here, m is raised to 1. And here it is m raised to a. That means, or I can say proportional, right? That means a's value should be equal to 1. You are equating the similar terms. Now I'm going to look at the L term. L here is raised to 1. Here L is raised to b, right? So L raised to 1 is proportional to L raised to b. So that means b's value is also equal to 1. Right. Now, what will be the value of C? Similarly, T, if I am equating, I will find the value C of value is how much? C is -2. Right. So, that means this block which is experiencing a force, that force dimension, I am going to rub it off, is equal to K m raised to A, right? A's value is 1. L raised to b, b's value is 1, and t raised to 2, right? -2 I have just written as denominator. Same as out of force equation. This is the simplest one, guys, because I wanted to make you understand how it is done. This is not a proper question. I'm just making you understand why we did it. So we got the expression of, this is actually not the force general equation. Here there is a term k included, right? So this k value can change. That is not known to you guys. So that means if there is a block, I am applying a force, that force is having this equation, which you have learned earlier. I think this is a you might having a confusion now. We'll do a simple question next step, then you will understand very easily how the problem is done and why we are doing this type of question. Okay. See, the question is like this. You know the pendulum, right? The pendulum, right? It moves to and fro. So this will be its mean position. It moves from to and fro like this. Then it moves like this. Right. Now say this pendulum, this entire string is having length L. Right. And mass of the bob is m. Right, and the acceleration due to gravity is g. These and all are the terms which you are given. Right, what are all are given? Pendulum is having the length L, mass of the bob is m, and the acceleration due to gravity is g. And you are told that the time period of oscillation of this pendulum depends upon this mass of bob, length of the pendulum, and g. Right? You are told these and all are the quantities on which the time period of this pendulum depends on. If it is so, what will be the expression or what will be the equation of time period? This is how the questions will be asked, guys. Right? So you will be given some terms on which your physical quantity depends on, and then you will be asked to find the exact equation of the physical quantity. We are given nothing, right? So what can I do? Listen, this is how all the questions has to be handled. In left hand side you are given this t, and you are told time period of a pendulum is a function of what and what? Length. Then you are told mass of the bob and acceleration due to gravity. Write it as it is. Then you can write t. This is proportional, right? T is proportional to L raised to A. I don't know that value, how much? M raised to B and G raised to C. Right? Now, in order to remove the proportionality, I will write a constant term K, L raised to A, M raised to B, G raised to C. Right? So, just we can write this much section. Right? Now, in the LHS side, I had time. Right? So, here I am going to write times dimension like this. So m0, L0, t raised to 1. That is the dimension of time. And in RHS, I will write the entire term like this. See, what was we written? It's of L raised to A, length raised to A. Then mass raised to B. But the problem is g raised to c. What is g? It is acceleration due to gravity, or I can say its dimension is acceleration's dimension, which is lt raised to minus 2. Right, that is your g. Right, so and that is raised to c. Right, now I am going to elaborate this much side, guys. K, right, L raised to A. Now here L is raised to C, right? The C is outside, can be brought in. So it will be L, C. Similar terms I am arranging together. Then there is M raised to B, and there is only T raised to minus 2C, right? Keep it as it is. Right, now I can just make it very easy. L raised to A and C means I can write it as L raised to A plus C. Then there is M raised to B, and there is T raised to minus 2C. Right? Simple. Now what was in LHS? It is M0, L0, T raised to minus 1. Now we will equate the similar term, guys. Very easy. One is take mass. Right? So when you take mass, B's value should be equal to 0. Right? Because both M can be equated, so I will find the B's value straight away as equal to 0. Very simple, right? Similarly, T is right sitting over here, here T. So I'm going to rub it off. T. So what was on the LHS side, guys? It was M0, L0, T raised to 1, right? So that means T raised to 1 term is 1. And what was the T raised to term in the RHS side? It was T raised to minus 2C. So equate these two, guys. I can easily say 1 is equal to minus 2C, or C is equal to minus 1 by 2. So you got this value. Similarly, you had B is equal to 0, right? Keep it as it is. Now here, in the same way, you are having L term, right? L is raised to 0 here. What was in RHS? L is raised to A plus C. So similarly, A plus C and 0 can be equated. So I can say A is equal to minus C. That is, A plus C is equal to 0. That means A is equal to minus C. So C's value is minus 1 by 2 means minus of minus becomes plus. So A's value is 1 by 2. So you got three terms value, A, B and C, right? Now why did I find this value? My end result was, or the end starting section I told you, L is equal to some constant into T, right? T is equal to, time period of pendulum is equal to some constant into length raised to A, right? Then mass raised to A and, B and G raised to C. This and all was the term, right? Now just move on, guys. So here K value I know. What is A term value? We just found A's value is 1 by 2. What is mass value? It was, or B's value, it was 0, right? I will write it like this. And G raised to C. What was C's value? It was minus 1 by 2. Now I will write the term in, or I am going to rearrange it, guys. So there is no mass, right? So need not write mass. L raised to 1 by 2 and G raised to minus 1 by 2 means there is a root where L comes above and G comes below. Listen, right? L raised to 1 by 2, G is below, so it is minus 1 by 2. So you now got the expression of time period of pendulum. Not the exact one. Exact equation is 2 pi into root of L by G, guys. This 2 pi is the constant value. That is the problem of this method, because you cannot get the exact value of this constant value. You just get a relationship between time period, length and G. By how much value or how the time period of a pendulum is depending upon its length and acceleration due to gravity can be deduced by what? Dimensional analysis. You cannot find by exactly by how much, but you can get a rough idea by how much. Similarly, I hope this much is clear. We'll do another question, guys. We'll do a lot of questions. even if you feel why we are guys, why this much questions are given, but as per me, how many questions you do, that much thorough your portion will be, right? Let's do the next question. It is with mass energy equivalence. This equation you know actually, but I am going to show you that this equation can be even deduced, that is E is equal to mc squared, this is your mass energy equivalence. This equation can be deduced by using what? Our dimensional analysis. Okay, right. Now the question is, you are told energy is depending upon mass of a particle and velocity of light. You're just told this much. So they again, just like any previous cases, what we will write? We'll write energy is a function of mass and speed of light. That means I can write E is proportional to mass raised to A and speed of light raised to B. Right. Then in order to remove the proportionality, I will write a constant K, M raised to A, C raised to B. Just like the previous cases. Same exact same steps. Right. Now what can I write? What is the dimension of LHS energy? It is ml squared t raised to minus 2. What is the energy dimension I have taken during the live class, guys? Right, is equal to K. Right, and here it is mass. I will write it as m raised to A. Now C is velocity. Velocity's dimension is LT raised to minus 1. Again, I have taken it earlier. And it is raised to B. We are just writing the dimension of each terms, guys. Right? Right? Now, just rearrange it. I am writing this one, removing the bracket. So, it will be LB. Right? Then it is T raised to minus B. Okay. Now, compare the terms. I am comparing mass terms. So, suddenly I found A's value is 1. Right, similarly B's value is 2. Right, see, this is equal to this, then this also B, right? So this, see, B's value is 2. So I found the value of A and B. Right, now substitute this value. Okay, substitute this value in this equation. Right, that means E's equation becomes K into M raised to A. This A becomes 1 and this B becomes 2. Right, so what is this expression? It is E is equal to K, M raised to A become 1, C raised to B becomes 2, or I can say it is K into MC square. This is the energies equation. We just derived the mass energy equivalence equation. Happy? That's why I told you this is very easy. So by dimension method, I have found what is the relationship between energy, mass and velocity of light. Right? Now let's do the last section, guys. After that, we'll go to the next topic. That is vibration. You are told that there is a string, right? It is tied at this section we will take in the last chapter of your +1 itself, but I will tell you, suppose the string is made to vibrate, right? So vibrating at a frequency mu, right? And you are told that this frequency of vibration depends upon the length, right, of the string, mass per unit length, okay, mass per unit length of the string and tension of the string. So listen when I am telling you, guys, that is frequency is depending upon length of the string, mass per unit length of the string and tension of the string. Right, these are the terms on which the frequency of vibration of the string is depending. Okay, so that means just like the previous section, I am going to write here mu is proportional or is function of length of the string raised to A, mass per unit length raised to B, tension. Remember, this is not time period, guys. It is tension raised to C. Right? So in order to remove the proportionality, what should I do? I write a constant, L raised to A, M, L raised to B, then tension T raised to C. Now, what is the dimension of frequency? What is frequency? Number of oscillations or to and fro motion in 1 second. Right? So, number of oscillations in 1 second. Right? So, number of oscillation is a number. Does it have any dimension? No. 1 second has a dimension, right? So, 1 by T. That is the dimension of frequency. Right? Number of oscillations by second in 1 second. That is your frequency. So, frequency's dimension is 1 by T or T raised to minus 1, guys. So, I am going to write in left hand side as T raised to minus 1. And in the right hand side, I am writing the same terms. It is K mass M raised to, mass per unit length was raised to B, right? Right. Then length was raised to A, right? Then there was tension. Tension is just like, actually it's like force itself. And what tension itself we will learn in the later on class. Now you just understand tension is the type of force. So in place of tension, I am writing the dimensional formula of force raised to C. Right. So just elaborate the terms, guys. So it is K bracket. Now I'm going to bring M terms closer. So it is M. Here there is a B and here it is C. So it is M and there is a C. Right. Now similarly I'm going to rearrange L terms. L, this is L raised to minus B. Right. And there is an L raised to A and here there is an L raised to C. Right. And T, there is only one term, that is minus 2C. Bracket closed. Now write the entire terms. M raised to B plus C, L raised to minus B plus A plus C, and there is T raised to minus 2C. Right? Clear? Now I'm going to rub it off, guys. Now that means in LHS term there is only time, which is T raised to minus 1. And similarly, what is in the RHS term? T raised to minus 2C. So that means C's value should be equal to 1 by 2. Very easy. Right? Now let's move on to the mass term. In LHS, does have mass? No. So M raised to 0. In RHS, it is M raised to B plus C. Right? So I can write B plus C is equal to 0 or B is equal to minus C, which is minus 1 by 2. Right? Now L raised to 0 in the LHS side. In RHS, L raised to minus B plus A plus C. Right? So that means I can just write it like A minus B plus C is equal to 0. You have got both value of B and C. Substitute the value. Minus B becomes minus of minus, right? So it becomes 1 by 2 and there is 1 by 2 is equal to 0, or I can say A's value is equal to minus 1. Calculation, listen, you guys can do it by yourself, right? So that's why I'm speeding up. This and all are very simple calculations. So I got 3 values, guys. A's value, B's value and C's value, right? And now where I'm going to substitute it? We had this function mu is equal to K into M raised to, what was it, L? It was L, right? So mu is equal to K, L raised to A, M raised to B and T raised to C. So here I am going to substitute as L raised to minus 1 mass per unit, right? So it is B's value is minus 1 by 2 and T was raised to 1 by 2. I can just rearrange it like this. K by L root of T by M. Right. That is the expression. This expression you will learn in the later on chapter, last chapter's waves. But you will get the expression by using dimensional analysis. This is how we are using dimensional analysis to find the expression of any physical quantity when you are given which quantities it is depending upon, right? You are given it depends upon tension, it is given depending upon mass per unit length and the length of the string, right? But you don't know by what can be the equation. Now we have derived an equation of these frequency, we have derived the equation of time period of a pendulum, we have derived the equation of mass energy equivalence, right? So by using which method, guys? By using dimensional analysis. I hope this much is clear. So guys, now we will discuss what is the limitation of this method, right? Why limitation? See guys, if everyone could have done or found equations which is round breaking equations by using dimensional analysis, then no one is going to do some experiments, right? So there is very large drawbacks by dimensional analysis, and one drawback I have told you, a limitation I have told you earlier, that is we don't find the value of this k, right? This is a constant value, and that means it is a dimensional quantity. So you cannot find dimensional constants value, how much it is, right? We just found a time period equation, remember? Previously we found it as k into L by G, and I told you actual the k's value is 2 pi. But by dimensional analysis I can never find this value 2 pi. Right, so this is one of the major drawback of dimensional analysis using for finding an equation, that is we cannot find this dimensionless quantity k. Right, now the second drawback is, see, correct dependencies must be guessed, right? So you are told initially that the frequencies equation, remember we were taught this is a function of length, mass per unit length, and tension, right? Suppose that block where the string is attached, I am going to consider its mass also. Let's say it is capital M. So the function will be L, then C, M. Let's say the tension is removed. You are not told anything about the tension. So in place of tension, I will write this mass of the block, right? So the frequencies equation which I will get will be entirely different from the earlier one, right? That means I will get a wrong equation. Right, so it's dependency on which and all term this function depends, that should be not approximately, should be correctly known. So the correct dependencies or the correct quantities, physical quantities on which this physical quantity depends should be properly given. Right, similarly, another third drawback is, see guys, you should be, or the dependencies should be limited in number, that is maximum 7 is only possible. So the same equation, that is frequencies term which we discussed, it can be said, someone says, okay, function, it is a function of length, mass, tension, acceleration due to gravity, then you are told Kelvin, that is temperature, then you are told ampere current, then there is mole, this is candela, that must almost all the quantities I am telling, that the frequency of vibration is depending upon all these quantities. So what would you do? You will write an A, here B, then C, D, E, F, G, H, you will go on and you will try to solve. That means, see, you know that there can be maximum how much? 7, right? Till our mole, there is only 7 SI units, or I can say only 7 base units, or Simon dimensional constant values. So if I write the entire thing, so till which value it is going to extend, it will be very large equations. So you will get a lot of equations which doesn't make any sense. So it is tell that since 7 is the SI unit basically, so the dependencies should be limited to the maximum, that is this values L, M, T, etc. This bracket section, that is the quantities on which this physical quantity depends, should never exceed 7. Right? This is not mentioned in your NCERT textbook. This is something which I am telling you voluntarily. So, and in your exam questions also, never you can expect more than 3 or 4, you can never expect, right? Almost all the quantities which on which the questions will be asked will be 3 or 4 dependency constants only, right? Now the last major drawback is, see, you are told there is a particle, it had an initial velocity u, it was moving with an acceleration a, and it covered a distance s, so that now its final velocity is v. So you can understand, right? So the velocity v is depending upon what is a function of what? Initial velocity, acceleration, and the displacement, right? Just by the question or the statement you can know. So you will write, for the solving, you will write it as u raised to x a raised to y, and then s raised to z, right? You will write like this and you will try to solve it. But the equation which you try to solve by this method, by dimensional analysis, you will get it as in this form only. Suppose x value is 1, y's value is 2, z, you just solved it. So you will write it as u squared a squared s cube, right? This is how you will write the expression. Have you ever learned an equation like this? No. But you have learned the actual equation is v squared is equal to u squared plus 2as, right? This is your correct expression. So by dimensional analysis, you got a wrong expression. Why? So that is where the last limitation comes. The dimensional analysis only works with multiplication or division equations. That is, it can never be associated with the equation like this. See, there is a plus term here. It is not a, if it had been, see, initially f is equal to me, that can be derived by dimensional analysis because there is only product term, there is no addition terms coming. But in this equation, see, velocities, dependencies, here there is a term plus, you are adding two functions. So this type of equations can never be derived using dimensional analysis. Only product functions or division functions can be derived by using what? Dimensional analysis. Okay, I hope you understood this class. Please, I have taken it in a slow pace because of very important topic. Take your time, understand the logic, pause the videos where you are not understanding and listen it. Okay guys, bye.